I want to begin with a very old story. You may have heard it. A man is searching for his keys beneath a street lamp late at night. A passerby stops and asks, "Did you lose them here?" And the man says, "No, I lost them over there in the dark." The passerby asks, "Then why are you searching here?" And the man replies, "Because this is where the light is." Now I have spent a great deal of my life thinking about what it means to search for things, and I have come to believe rather firmly that the scientific community, in its search for extraterrestrial intelligence, has been behaving very much like that man under the street lamp. We search where it is convenient. We search where our instruments already point. We search where our assumptions tell us to look. And we have been doing this for more than 60 years with remarkable confidence and, I must say, equally remarkable failure. I do not say this to be unkind. I say it because I think we can do better. And doing better requires first the courage to admit that we may have been searching in entirely the wrong place. Let me explain what I mean. When people think about the search for alien life, what scientists call SETI, the search for extraterrestrial intelligence, they almost always think about radio waves, the great dish antennas tilted toward the sky, the banks of computers listening through the night. The dream, borrowed partly from science fiction, partly from Frank Drake's original Project Ozma in 1960, that someday a repeating signal will emerge from the noise and we will know at last that we are not alone. This is a romantic picture. I understand its appeal. I shared it once in some part of myself. But I want you to think carefully about what this picture actually assumes. It assumes that alien civilizations want to talk to us. It assumes they are pointing their transmitters in our direction. It assumes they are using radio frequencies that we happen to be monitoring. It assumes, in short, that the universe is arranged for our convenience. And I have lived long enough as a physicist to know that the universe is not in the habit of arranging itself for our convenience. There is a deeper problem here, and it goes to the very heart of how we think about intelligence in the cosmos. When we search for radio signals, we are searching for aliens who think like us. Aliens who have decided, as we have decided, that radio is the medium of choice. Aliens who are at a technological level roughly comparable to our own. Aliens who are, in some fundamental sense, us only located elsewhere. This is what philosophers call anthropocentrism, and it is, I believe, the greatest intellectual trap in the entire enterprise of searching for life beyond Earth. Think about what it means to be a truly advanced civilization. Not a civilization 50 years ahead of us or 500 years ahead, but thousands of years ahead or millions. What would such a civilization look like? What would it need? What would it be doing? I would suggest to you that the most pressing need of any sufficiently advanced civilization is not communication. It is energy. This was the reasoning that led me back in 1960 to write a short paper in the journal Science. I was thinking about the problem from an engineering perspective, which is, I confess, where I am most comfortable. I noted that our own sun produces every second an almost incomprehensible quantity of energy, roughly 400 trillion watts, and yet we, living in the vicinity of this extraordinary furnace, manage to capture almost none of it. The sunlight that falls on our rooftops, the solar panels we occasionally install, these are gestures. They are the cosmic equivalent of warming one's hands beside a candle while standing next to a volcano. Now, suppose a civilization has been developing its technology for 10,000 years or 100,000. What would a rational engineer do with a star? What would you do if you had the capability? The answer seems almost obvious once you ask the question honestly. You would build something to capture that energy, something large, something that surrounds the star, or at least a significant portion of it, something that intercepts the light before it escapes uselessly into the void. This is what has come to be called a Dyson sphere, though I must confess that name always makes me slightly uncomfortable, as if I am taking credit for an inevitable idea. The concept is simple: a shell, or more practically a swarm of orbiting structures enclosing a star and converting its light into usable energy. The details of how such a thing would be built are engineering problems, not physics problems, and I have always believed that engineering problems, given sufficient time and intelligence, get solved. But here is the critical point, and this is what I want you to understand very clearly. A civilization that has built such a structure would, from our vantage point across the galaxy, be invisible in ordinary light. The starlight that we would normally see from such a star would be absorbed, captured, used by the surrounding structure. What would be emitted instead is waste heat, infrared radiation, the cool, dim glow of a civilization consuming the energy of its sun. In other words, a truly advanced civilization would not be where the light is. It would be where the light is not. This is the reality check I want to offer you today. We have been listening for radio signals from civilizations roughly like our own, but if there exist civilizations millions of years more advanced than us, they would be doing something far more consequential than broadcasting radio waves. They would be engineering their stellar environment, and their signature would not be a clever pulse in the radio spectrum. It would be an anomalous dimming of a star that produces far too much infrared light, a star that seems for no natural reason to have gone quiet. Now, I should be honest with you about the limits of this idea. When I wrote that 1960 paper, I was thinking as an engineer. I was asking what a rational civilization would do with available resources, and I believe that question is worth asking. But I also believe, and I have said this publicly, that the assumption that alien intelligence would follow our own engineering logic is in the end probably wrong. A civilization that has been evolving for millions of years might have priorities and methods so alien to ours that we would not recognize their works, even if we were looking directly at them. This is not despair, this is humility, and I think humility is exactly what the search for extraterrestrial intelligence has lacked. Consider the Fermi paradox. Enrico Fermi, a man of considerable intelligence, as you may know, asked a deceptively simple question at lunch one day at Los Alamos. He said essentially, if the universe is old and stars are abundant and life arises with some reasonable frequency, then where is everybody? Where are the aliens? Why haven't they shown up? Why haven't we heard from them? This question, stated in those few words over a cafeteria meal, has occupied serious scientists for 70 years and has not been satisfactorily answered. The standard responses are familiar. Perhaps life is rare. Perhaps intelligence is rare. Perhaps civilizations destroy themselves before they can travel the stars. Perhaps they are hiding, watching us, waiting for us to mature. Perhaps, and this is the most unsettling possibility, we have already been contacted and simply failed to recognize it. I want to propose a different way of framing the question. Perhaps we have not heard from them because we have been listening on the wrong frequency, in the most general sense. Not just the wrong band of the electromagnetic spectrum, but the wrong category of signal entirely. We have been listening for speech, for the deliberate intentional broadcast of information. But intelligent life at sufficient technological maturity might leave far more fundamental traces in the structure of the galaxy itself. Imagine looking at the distribution of stars in a nearby galaxy and noticing that certain stars emit far less visible light than they should, given their mass and temperature, but emit a corresponding excess of infrared radiation. This is precisely what we would expect from stars, encased in energy-harvesting megastructures. In 2015, researchers actually searched for this signature in a survey of roughly 100,000 galaxies. They found some intriguing candidates, galaxies that seemed to radiate unusually large fractions of their energy as infrared rather than visible light. Were these alien civilizations? Almost certainly not, or at least probably not. There are natural explanations involving dust, but the exercise itself is important. We were, for once, looking in the darkness rather than toward the light. And then there was the star that briefly captured the world's imagination, Tabby's star, formerly known as KIC 8462852, discovered in 2015 by the citizen scientists of the Planet Hunters Project, working through data from the Kepler telescope. This star dimmed irregularly and dramatically in ways that no known natural process could straightforwardly explain. For a brief, exciting period, people were willing to say out loud that it might be alien megastructures, perhaps not a full Dyson sphere, but something in the process of construction, or something we simply did not understand. The follow-up investigations pointed towards circumstellar dust as the most likely explanation, probably. But the episode told us something important. We had for the first time taken seriously the idea that the evidence of alien engineering would look like an astronomical anomaly, not like a radio message. This is the correct instinct, and I believe we have been too slow to follow it. Let me turn to a somewhat different aspect of this problem because I think it is equally important and equally neglected. We tend to assume when we speak of alien intelligence that we are speaking of beings, of creatures with bodies and minds and intentions. creatures who might want to talk to us or might be afraid of us or might simply not have noticed us. This is again the projection of our own nature onto the blank screen of the unknown. But consider the possibility that intelligence at sufficient age migrates from biology into something else entirely. We ourselves are already beginning this process. Our computers perform calculations that no human brain could accomplish in a lifetime. Our communication networks carry information at densities and speeds that our neurons could not approach. If this trend continues, and I see no reason why it should not, then the distinction between biological intelligence and technological intelligence may dissolve within a few centuries, perhaps less. A civilization 1,000,000 years old may not consist of creatures in the biological sense at all. It may consist of something we would call, for lack of a better word, a mind, a vast distributed intelligence embedded in the computational structures of its environment. Such a mind would not send radio signals. Such a mind would not need to. It would be occupying itself with problems of a different order entirely, problems in mathematics perhaps, or in physics, or in the management of stellar energy on timescales we cannot easily contemplate. This is not science fiction, although science fiction has explored it with great enthusiasm. It is a serious possibility that follows from taking our own technological trajectory seriously and projecting it forward in time. And its implication for the search for extraterrestrial intelligence is severe. We may be looking for the wrong kind of thing entirely. I want to say something now that I think will strike some people as unsettling, but which I believe needs to be said clearly. The biggest mistake we can make in thinking about alien life is the assumption that it must be recognizable to us. Not just in the physical sense. We have made some progress in admitting that alien life might look very different from life on Earth, but in the deeper cognitive sense. We assume that alien intelligence, however different in form, would have goals and values and ways of organizing information that we could in principle understand. We assume that there is a common ground of rationality, a shared logic of the cosmos that would make translation possible. I am not sure this is true, and I am not sure that admitting it is cause for despair rather than wonder. Science is not a collection of firmly established truths. It is a continuing exploration of mysteries, and the mystery of whether we are alone in the universe is, I would argue, among the deepest mysteries we face, not because the answer will change the laws of physics, it will not, but because it will change our understanding of what the laws of physics have made possible. It will change our sense of what we are. I have sometimes been asked whether I believe in alien life. The question is posed as if it were a matter of faith, like asking whether I believe in God. I try to resist answering it in those terms. What I believe is this: the universe is very old and very large, and the processes that produced life on Earth were, as far as we can tell, the ordinary processes of chemistry operating under physical laws that apply everywhere. There is no reason in principle why those processes should not have operated elsewhere. The question is not whether life exists elsewhere, I think that is almost certain, but whether intelligent life exists elsewhere, and whether that intelligent life has left any trace that we might find. And on that question I genuinely do not know. I think the honest answer is that nobody knows. We have been searching for 60 years with radio telescopes, and we have found nothing definitive. But 60 years is nothing. It is less than the blink of an eye on cosmic timescales. And we have been searching in one narrow way, driven by one narrow set of assumptions. When the universe is almost certainly richer and stranger and more varied than anything our assumptions encompass. What I am arguing for is a broadening of our search, not an abandonment of radio astronomy. That work is valuable and should continue, but a willingness to look in other directions, to ask other questions, to look not just for signals but for structures, not just for transmissions but for transformations, anomalies in the behavior of stars and galaxies that might indicate the presence of engineered systems operating on scales we have barely begun to imagine. We should be looking at the dark stars, the ones that emit far more heat than light, the ones that dim in ways we cannot explain, the ones that have been quieter for longer than they should be. We should be building better infrared observatories, not just bigger radio dishes. We should be analyzing the large-scale structure of galaxies for signs of civilizational engineering, rather than waiting for a phone call that may never come. And we should, above all, have the intellectual honesty to acknowledge that our assumptions are assumptions and not certainties. The history of science is full of confident majorities who turned out to be wrong, not because they were foolish people, but because they were human, and humans find it difficult to think outside the categories that have already proven useful. Heretics are needed. Not heretics who deny the evidence, but heretics who insist on looking at the evidence we have been overlooking. The light we have been following, the comfortable familiar glow of radio waves and optical signals, may be leading us away from where the answer actually lies. The answer may be in the darkness. It may be in the infrared glow of a star too warm in ways we have not yet understood. It may be in the absence of starlight from a region of the galaxy that should by all ordinary expectations be glowing. Alien life, if it is out there, is not waiting for us to point our radio telescopes in the right direction. It is not composing messages in binary arithmetic for our eventual reception. It has had millions of years to become something we cannot easily imagine, and the evidence of its existence, if such evidence is to be found, will probably not look like a signal. It will look like a mystery. It will look like something that does not fit our models. It will look like a question that we do not yet know how to ask. That is, of course, exactly what science is for. Not the answering of questions we have already framed, but the discovery of questions we did not know we needed to ask. I have spent my life being what people sometimes politely call a heretic. I have questioned consensus on any number of issues, and I have been wrong more than once, which keeps me honest. But on this particular question, the question of whether we are searching for alien life in the right way, I am fairly confident that the consensus is too narrow, too radiocentric, too committed to the vision of alien intelligence as a civilization that sends messages, rather than a civilization that has long since moved on to other things. The universe is not arranged for our convenience. That is the first thing a physicist learns. The universe is strange and old and full of processes we have not begun to understand. If intelligence has arisen elsewhere in it, and I believe it has, then that intelligence has had time to become strange in ways that we cannot predict and may barely be able to recognize. We should not stop searching, but we should search differently. We should search humbly, with our assumptions held lightly, and our instruments pointed not just toward the familiar light, but into the unfamiliar dark, because that, I suspect, is where the answer is hiding. Thank you.